Okay, hello everyone. So I'm going to be taking you through the question you did in your test one. So yeah, I'm also going to cover everything from here. I'm also going to cover this stuff here. So from here up to here. So basically, this question we've been given an IAS, right? We've been given memory contents of the IAS. So we've been given this memory contents, and then we've been given these tables here to keep track of what's going on with the registers, and then we have this table here that gives us what the opcodes are, right? The opcodes and the instructions they represent, right? So if we have, let's say, 00000010, that's load MQ, right? So load memory contents to accumulator, etc., etc., right? Contents of register MQ2, yeah. Then I have this flowchart here that I'm just going to be using to, well, guide us as we go on solving these things, because this is actually a very useful flowchart, right? And I've written the numbers there, so please try to follow along as we start this one. So first thing is the first one over here, right? So we have our program counter starting at 05A, right? Our program counter starting at 05A, right? What is at 05A? The contents of 05A are these, right? This is our content. Now, one quick note about the IAS is the way this memory works, right? The way IAS works. When we're reading an instruction during the fetch cycle and read something from the IAS, we basically split it into two. We have the left hand part and the right hand part. For the left hand part, what we have is that the first 8 bits, right? The first 8 bits, or this 0 and 1, because this is in hexadecimal, so each number here has 4 bits. So the first 8 bits here, the 0 and the 1, are the opcode, and then the remaining 12 bits are the address, right? And then same thing for this one. So here 21, this is 8 bits, then 08B, this is the address, referring to these addresses here, right? And we're just going to try and keep track. So first thing is fetch, right? What happens in the fetch cycle? We look at this guy. So in the fetch cycle, first of all, when we start our fetch cycle, what we see is that we check, is the next instruction in the IBR? In this case, we have nothing in there, right? So that's the first thing we do. The MAR, right? The MAR in this case will have the contents of the program counter, and then the MBR, right? The MBR will have the contents of whatever was fetched from memory, right? And then we're still in the fetch cycle here, but what we do is that the left instruction will be required the first time we run this. So when you go in this case, right, our instruction buffer register has the second part of the instruction that we fetched, right? The right hand instruction. Our instruction register will get the contents of the MBR, right? We'll get the instruction part, and then our memory address register will get the address part of our instruction, right? So that's what we're going to do essentially, right? So essentially that's what we're going to be doing. Okay, so in this case, what do we know? So first of all, one here is our memory address register. This, according to this flowchart, what we know according to this flowchart is that our MAR, first of all, have the contents of the program counter, right? So the contents of the program counter. Then again, it will have the contents of the memory address register, right? So at the beginning there, it has the contents of the program counter, which is 05A, right? Then now we have our memory buffer register, right? Our MBR. This MBR will have the contents of whatever we fetch from memory, right? Or whatever we fetch from memory, right? So what are we fetching from memory? We're fetching 0, 1, 0, 8A, 2, 1, 0, 8B, right? Next, we have our accumulator. Our accumulator in this case, we don't know what's there, so we just assume it's initially empty, and you can set that as a 0, you can put that as a dash, because we don't know what's there anyway, right? Then we go on to 4. What's at 4? Our instruction register. Remember, our instruction register will get the opcode of the left hand instruction, in this case 0, 1. Then from instruction register, instruction buffer register will keep this guy over here. So we're going to have our 2108B. Right. Then we go on to 6, the program counter. In this case, since we haven't executed both instructions here, if we go and look at this guy over here, right, the instruction register, the program counter only increases after this pass, right? So after we execute the first hand instruction, then we come to the right hand instruction over here. That's why now program counter will increase by 1. So basically speaking, the program counter in this case will stay as 5A, right? The program counter in this case will stay as 05A. Stay as 05A. Then now our memory address register. Our memory address register is 01, because 01 is the address. Is 08A, because 08A is the address of our what? Is the address that our instruction is pointing to, right? What next do we have over here? After that, we have the memory buffer register. The memory buffer register, we're basically getting, for the memory buffer register, we're basically getting what's in memory, right? Whenever something passes through memory, what you notice from the flowchart, whenever something comes from memory, it has to go through the memory buffer register first, right? So that's why the memory buffer register will always have whatever was coming in from memory or going out into memory. So in this case, right, where are we? We're on 8, right? On question 8. So 8 there, the contents of our MBR will be the contents of 08A, which is just F, 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 B. This, if you translate it, is just -5, because these numbers are stored in 2's complement, right? The numbers here are stored in 2's complement, so this is just -5, right? This is -5. Okay, then now what goes into our accumulator? So this instruction, and I didn't even explain it, but 0001, this one over here, this is the instruction we're referring to. Let me use 01 is this one over here. Let me use red. It's this instruction over here, which is basically load mx, right? Then transfer mx to accumulator. So explained what 01 meant here, but basically this instruction 01 is get whatever is at this memory address and load it into the accumulator. So we executed 01, right, which got the contents of 08A, which is this here, which we're then going to pass through the memory buffer register, and then it will also go to our accumulator finally, right? Goes to our accumulator like that, right? Okay, what now do we have? So this is question 10. Question 10 is our instruction register, right? Our instruction register still has our 01 there, right? We don't change it. Even if you look at the flowchart, we only change our instruction register once. We don't change it during our instruction cycle. So you can always just refer to this flowchart, which does explain the entire overall process of how to go about this. Then 11, instruction buffer register. Our IBR will still contain our 21, right? Our 210, right? Our 210 8B there. Okay, so what do we have now at 12? At 12, and I don't have the paper with me right now, it's only this one. In fact, let me bring it up on my device here, just so I can be monitoring. So 12, we have our program counter. So our program counter, this is the second instruction, this is the second fetch cycle, so instruction number 2. Our program counter, it's still going to be at 05A, right? It's still going to be at 05A. It will only change in our execution cycle, right? Because we only modify it. If you look at this, our program counter only changes right before we enter what? It changes right before we enter our execution cycle. That's why we're going to maintain it for now. 13, what's 13? 13 is our memory buffer register, right? 13 is our memory buffer register. Now, it's our memory address register. So this one in this case, this memory address register, if we look at this flowchart, immediately here we change our MAR to whatever is in the buffer register there for the instruction. So the MAR is going to have 08B, which is that address over there, right? Then what's going to be with 14? 14, our memory buffer register is still going to contain F, 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 B there, right? Still going to contain that. Then our 15 as well, our accumulator is still going to contain F, and then you already know what it looks like. It's just FF. Yeah, so it's just a continuous F's with B's there. Then our instruction register at 16 will contain our 21, which is this instruction over here, right? And then at 17 we still have in the memory buffer register, remember we haven't cleared that register, so we still have 2108B. We still have those contents in there. Then on 18 now, what happens at on 18? Remember, we've executed the second instruction. We're here now. The first one, we executed this instruction. Now we've executed this one. So what do we do? In this case now, we increment our program counter. In this case now, our program counter at the beginning of this execute cycle will be 0, 5B. Right? What would be 19? 19 in our memory address register, we're going to have this memory address 08B, because we've already changed it here. We haven't made any changes to it. Yeah. Then now 20, what would be in our memory buffer register? So first of all, we look at this instruction 21. What does instruction 21 mean, right? 21 is 100001. This one. This is our instruction. This is our instruction 21 over here. Some red ink. This is our instruction 21 over here. The third one, which is store. So transfer contents of accumulator to memory location X, right? This is what 21 is doing. So we're going to get the contents in the accumulator. What's in our accumulator? Our accumulator has this FFFFFB, right? So first of all, it will pass through our MBR. Remember, anything that leaves or enters memory has to pass through the MBR first, as you notice from here. So this is more like our which is this one? This is MBR. So contents of memory. AC to M. Where is that instruction? Okay, no, it's not. But just not everything that passes through our almost everything that passes through our through and from memory has to pass through the MBR. So our MBR will still maintain our FB, right? Our AC still has that FB, right? But then this value here has been stored in this memory location according to what 21 is in our instruction set, which is this one over here. So this 21 is store the contents to memory, right? Then we're going to have our 22 being our instruction register. Again, it will still maintain that 21. Then our 23 will still be 2108B. Okay, now we go on to 24, the second instruction. I'll cut this video here, then I'll continue it in the next part. Yeah, that's so I don't get any corrupted video.